So welcome to this presentation of decimal to binary conversion. We'll learn here how to take a decimal number and convert it to its binary equivalent. There's only one learning objective for this lecture. We're going to show you how to convert a decimal number, any decimal number, to its binary equivalent. So we're going to convert a decimal number to its binary form. In order to convert a number, we need to pick one or two. And so down at the bottom of the screen, I've selected 7 and 89. What we'll do is walk through those two numbers, convert them to binary, and then we'll know the procedure. Well, the first thing you do, grab a piece of paper, and up at the top of the piece of paper on the right, write the number 1. Then write the number 2. What you're going to be doing is doubling the number each time. So we're going to double the number, place the new number to the left of the last number, and just repeat 4, 8, 16, and so on until you get a number that is bigger than the number you want to convert. Well, it turns out the largest number we're going to work with here today is 89. So 64 is not larger than the number we want to convert. So we'll go one more double and get to 128. So what we've done is now is written down all the numbers from 1 to 128 by doubling them. And this doubling is important because the numbers that you're now looking at are the column weights of each of the digits in a binary number. You know the column weights of decimal numbers. The column weight of the first column is 1, the second column is 10, the third column is 100, the next column is 1,000, and so on. Why? Because it's decimal or a base 10 number. This is a base 2 number, so each column has a weight of twice the previous column, not 10 times like in decimal. Well, let's pick a number. Here's our 7. Let's work on 7 and see how we do that. Well, rule 1 is the most important rule. Find the largest number that is equal to or less than our number 7. Largest number equal to or less than 7. Well, that rules out the 8, the 16, the 32, and all the numbers larger than 7. So we're left with 4, 2, and 1. And it's important that we pick 4. We can't pick 2 or 1, and that's why this says the largest number equal to or less than. Of the numbers 4, 2, and 1, there's only one number that's equal to or less than, and that's the largest one, and that's the 4. So we're going to concentrate on that 4 for a second. So what we're going to do is we're going to place a 1 underneath that number 4 to indicate that the number 7 is at least 4. It has a 4 in it somehow. So since 4 is a number, let's place a 1 under the 4. Well, now that we know that our number 7 has 4 in it as part of it, then we have to say, well, okay, we've accounted for 4 out of the 7. What's left? In other words, if we're trying to get to 7 and we've taken care of 4, we're going to have 3 left. So we simply do the subtraction. In this case, we subtract what we started with, the 7, and we subtract the 4 from that, and it leaves 3. So that 3 says we've accounted for 4, we've got 3 left to account for. Now, since we have 3 left, we can look at the 2 column for a second, and we can say, well, if our real number was 4, we'd be done because the number 1 represents a value of 4. If our number was 4, we'd be done, and we could fill in the 2 and the 1 column with zeros. But that's not true. We have the number 7, not the number 4. Since we have a remainder of 3, we again say, what's the largest number in our list that's less than or equal to our remainder, which is 3. And of course, that number is 2. So we're going to place a 1 in the 2's column. So now we've accounted for 6. 4 plus 2. Our remainder of 3 now needs to be reduced by the 2 that we just accounted for. And 3 minus 2 is 1. So we still have 1 unaccounted for. And of course, since the far right column is 1, and we have 1 to account for, we can put a 1 in that column, and we're done. So the number 111 in binary is the same quantity as the number 7 in decimal. So we place that last 1 as our last digit in our binary number. What does 111 mean? It says, give me a 1, give me a 2, and give me a 4. And if you give me one of each of those, I can add them together and get the number 7. Just like if this was a decimal number, 111, that would be saying, give me 1 1, give me 1 10, and give me 1 100. And if I added those 3, I'd have 111. So in each number system, they're all the same. You just add the column weights that they represent to get the final number. So we now know that 111 represents the decimal number 7. Well, I'm going to zero fill the rest of the numbers. I'm going to put a 0 under the 8, the 16, the 32, the 64, the 128. I'm putting those zeros there because we don't store 111 in computers. If I wanted to store the number 7 in a computer, it would be stored as 000000111. And the reason for that is we normally store numbers in computers in increments of 8 or 16 or 32 ones and zeros. We call those each bits. So what I've done is I've made our number 7 an 8-bit number. We can also do this in decimal, but it doesn't make sense in decimal. We know to ignore leading zeros. And here, as far as the quantity, we can ignore the leading zeros, but we can't ignore it in the computer because the computer has to store something in each of those bit positions, and you can't store a nothing. You can't store an empty bit. The bit must either be a 0 or a 1, so we zero fill. So the number, the blue number that you see at the top, represents the 8-bit representation of the number 7. Well, let's take a look at the number 89. Same idea, same concept. First, when we look for the number, we're looking for the number, the largest number that's less than or equal to 89. Well, the 128's too big. It's not less than. So the largest number that's less than 89 is 64. So we know that there's at least 164, or there is 164, in the number 89. So we can put a 0 under the 128 to say we don't need any 128s. That's not part of our number. And then we can say, well, 64 is the next highest number. So we're going to put a 1 underneath the 64. Now, if we don't put the 1 there, all of the numbers to the right, 32 plus 16 plus 8 plus 4 plus 2 plus 1, will not add up to a number big enough to give us 89. We've got to have the 64. We've got to show that this number contains 164. So we're going to put a 1 in the 64's column. So what this says is our number is at least 64. And how much more than 64? Easy. Take the 89, subtract the 64, that's how much we have left. So once you place each digit, then we say, okay, we've used up 64, we need to get to 89, what's left? And of course the easiest way is do the subtraction. In green on your screen, you'll see 89 minus 64 is 25. So that tells you that we need 25 more to get to our total of 89. So let's do that. Well, we need 25 more. We don't need 32. 32 is too big. So 32 is bigger than the 25 we need. We can't put a 1 there because a 1 would give our total right now as 64 plus 32, which is 96. We're too high. We've overshot 89. So the 32 column is going to have to contain a 0. So we put a 0 in the 32 column. We're back to our 25. Okay, is there 116 in 25? There sure is. So we're going to need to grab 116 to take care of our remainder of 25. So we do that. So we put a 1 in the 16 column. Well, we needed 25. We just grabbed 16, right? So what's left? When we do the subtraction, we need 9 more. So we continue this process until we get to no more leftovers in our number or we get to the end of the number, and everything should work out. Now, we can take a shortcut here. Watch this. We know we have 9 left. Look at the numbers that are left, 8, 4, 2, 1. How can I come up with a 9 with those numbers? What's going to give us the 9 that we need? Well, what about 8 plus 1? What if we add an 8 to our number and a 1 to our number? Doesn't that give us the 9 we're looking for? Sure enough. So when we get near the end of the line here, we can say, oh, we can do a shortcut. We can say that 9 is equal to 1001. Why? Because the left-hand one is the 8's weight column. The right-hand one is the 1's weight column. 8 plus 1 is 9. So 1001 is equal to 9. We can put 1001 in as the last 4 digits of our number, and we're done. So there's our number, 01011001. That sequence of ones and zeros in binary represents the decimal number 89. So what I'm going to do in the next slide, I'm going to place 5 numbers on the slide, and then you'll see a countdown on the screen. The countdown on the screen will go from 5 down to 0. When the countdown hits 0, I'm going to show you all the answers. So if you want to stop the video, work out the numbers, convert them each to binary, then when you see the countdown or as soon as you see the next slide, hit pause on your video. That will allow you to look at the numbers on the screen, convert each one to binary on your own time, and just take your time doing it, get them right, and then when you've got all 5 numbers, resume the video. The countdown will go to 0, and when it goes to 0, we'll have our answers, and I'll walk you through each of the answers. Here we go now. So, pause now. I'm going to do countdown to 0, and then we'll look at the numbers. So there we go. There's the answers. Let's look at each one and see how we arrived at each of those numbers. And you can look at the numbers you wrote down and see if you got the correct answer. Well, let's pick the number 11. If we look at the numbers at the top of the screen and I said, hey, give me numbers that add up to 11, it's pretty easy to say, well, that's easy. The 8 plus the 2 plus the 1, that's 11. So what we need to do is we need to have a 1 in the 8's column, a 1 in the 2's column, a 1 in the 1's column. And as you can see, our number, 4 zeros, 1011, has just that. It has a 1 in the 8's column, a 1 in the 2's column, and a 1 in the 1's column. And over on the right, we add up 8 plus 2 plus 1, we get 11. That's our conversion. 11 is now represented in binary form. Let's look at the number 32. 32 is easy. The number 32 has its own column, doesn't it? So if we put a 1 under the 32 and fill all the rest of the position with zeros, we're representing the number 32. So that one's easy. How about the number 85? Well, this is a little harder work. It's kind of like our number 89. We've got to start on the left. Find the largest number that fits. Well, the largest number less than or equal to 85 is 64, so it contains at least 164. Well, once we've subtracted 64, we got 21. 21 doesn't work. 32 doesn't work with 21. It's too big. So the first number that fits into 21 is 16, so we're going to have a 1 in the 16's column. And we continue that, and we find that we're going to have a 1 underneath the 64, the 16, the 4, and the 1. Because when we add those 4 numbers up on the right, we're going to wind up with 85, our decimal number. And we've got a winner. Let's pick the number 100. Same idea. What numbers at the top will add up to exactly 100? Well, 64 and 32 look close, but that's 96, isn't it? So the 64 and 32, if they have ones under them, and if everything else was a 0, we'd know the number was 96. But we want 100. We need 4 more. Over to the right, grab the 4, add it, and we've got 100. 64 plus 32 plus 4. And the last one, I picked one with the maximum number of zeros here underneath 128. We picked the number 127, and sure enough, the 127 takes everything. It needs a 64, a 32, a 16, an 8, a 4, a 2, and a 1. So our number 127 is 0, 1, 1, 1, 1, 1, 1, 1, or a 0 and 7 ones. And remember, the 0 is a 0 fill because these are 8-bit binary numbers. And so the left-hand zeros we fill with zeros so that we wind up with 8 bits or 8 digits, because that's how we store binary numbers in computers. So we've completed 127. We're done. We've got the idea. If you can do these numbers, then you know how to convert from decimal to binary. So here's a summary if you like a procedure. At the top of a piece of paper, write the number 1. Keep doubling it to the left until the number you write is equal to or greater than the number you wish to convert. So if you wanted to convert 1,000 in decimal to binary, you'd have to double the 128 to 256, the 256 double it to 512, the 512 to 1024, and that 1024 is larger than 1,000, so we've gone far enough, so we'd have to have a couple extra numbers. So if you're going to do big numbers, you have to keep doubling until you get to that big number or something larger. So that's step number 2. Step 3, I'm going to ask you to call the number you're starting with the remainder, because we're going to keep subtracting from it. And so each time we subtract, there's going to be a remainder, and we have to handle what's left of a remainder. So I'm going to ask you to just call it the remainder for now. And right now, of course, your remainder is whatever number you picked, but it's going to get smaller each time you place a 1 on the chart. So start on the left, find the largest or the first number that's equal to or larger than the remainder, then subtract that number and put a 1 there. So put a 1 underneath that number, subtract that number, that gives you a new remainder, and then you're going to continue down the line, one digit, one column at a time, until you either get your remainder to 0 or you've gotten all the way down to the 1 and placed a 1 or a 0 underneath the 1. When you're done, any numbers that don't have anything underneath them, put a 0 underneath and you'll be done. So that's it. That's a procedure for how to convert decimal to binary. I hope you like that. I tried to keep it short and sweet and simple so that you could understand the process. Thanks for listening.